This conference will now be recorded.
All right, this is a video of some of the examples that we, I believe, skipped over in the section on the sum and difference rules for derivatives. So we did a few of these in class, but like I said, we skipped some. So we're looking at finding the derivative of y equals t cubed minus 4t. And remember, we call that y prime, and we're just using the power rule, which says you bring the power on your base to the front, times it by the coefficient there, and then you lose a power. So this would be 3t squared minus 1 times 4 would be 4. T to the 0 would just go away and become a 1. So that would be our derivative there. For number 2, f prime of x, this would be 4 times 2, which is 8, x to the third. 3 times negative 5 is negative 15, x squared, and then the constant, remember the derivative of a constant is 0. Another one I don't believe we did was number 4. So g prime of t. We need to bring the 4 to the, or the 1/3 to the front and multiply it by the 4. So that would be 4/3. And then that's going to be a negative when we subtract, because we're going to do 3 over 3 subtracted because we're losing 1 power. So that's going to be negative 2/3 and then minus 6. So to write that in a final format, it would be 4 over 3t to the 2/3 minus 6. And we did 5 and 6, I believe, in class. I think the only one of these I did was the very last one, so we're going to go through these. Find the slope of the graph using, this is our function and the point 2, negative 5. So remember, all we need from that ordered pair when you're just finding the slope is the x. But before you can do that, you need to find the derivative. So f prime of x equals 2x minus 5 using the power rule. And then we plug in the 2. So that's 2 times 2 minus 5, or 4 minus 5, which is a slope of our tangent line at that value, x equals 2, is negative 1. All right, so let's do this one. So this would be y prime is 3x squared minus 4. Y prime evaluated at 0, since that's the x coordinate, would be 3, 0 squared minus 4, which is just negative 4. So the slope of the tangent line is negative 4 at the x value of 0. Okay, and then let's look at this one. So we're doing the equation of the tangent line, which means we need to find the slope first, and then we have to plug into the y minus y1 equals m parentheses x minus x1. So let's find our slope first, and remember negative 1 is the x value we're going to be using in a minute. So g prime of x, bring 4 to the front, times it by negative 1/2, that would be negative 2, x to the third power. 3 times 3 would be 9, x to the second power, minus 2. I need to find g prime at negative 1. It's negative 2 times negative 1 cubed plus 9 times negative 1 squared minus 2. If you cube a negative, it stays negative. If you square a negative, it's going to go positive. So this is 2 plus 9 minus 2, or just 9. So remember, that's the slope of the tangent at x equals negative 1. So now we want to find the equation. So we're going to use our slope and our point. So y minus negative 3/2, which will be y plus 3/2, equals 9 parentheses x minus negative 1, which would just be x plus 1. You could go ahead and distribute the 9 if you would like. So that's 9x plus 9. Some people will get rid of their fraction here. If you multiply everything by 2 all the way across, that includes everything. That clears out that fraction, but it makes everything else double. We would subtract 3. So that's 15. And then divide everything by 2. And you didn't have to do that. You could have used your calculator to work with the fractions. Just showing you an alternative way to do it by hand. So y equals 9x plus 15 over 2. So that was all from section 2.2. In 2.3, I believe we skipped over a couple examples on the marginal page. So we did not do this very first one. The profit in dollars derived from selling X units of an alarm clock is given by P equals 0.0000 2x to the third plus 10x. Find the marginal profit. That means we're finding the derivative. So we're looking for, this is the profit function, so we don't have to find it. They gave it to us. So we're looking for dp dx or p prime. So if we bring the 3 to the front and multiply that by that, that'd be 0.0006 x to the second plus 10. And then they told us that our x units is going to be 50, so we can evaluate that now at 50. So let's work that out on our calculator. So this is 50 squared times 0.000, oops, too many zeros, 6, and then plus 10. Looks like it's 1150. So we are estimating, remember the marginal profit's kind of the slope of the tangent. We think if they up to 51 units, the marginal profit estimates, or estimates I should say, at the 1150. Okay, so now it says compare the marginal profit with the actual gain in profit obtained by increasing the production level from 50 to 51. So when they say actual, you want to deal with the slope of the tangent or the secant line. So you're actually finding what is 50 and 51 plugged into the original function. You get the two ordered pairs and you find the slope the old-fashioned way. So this is, we want to plug in 50 into the original function. 50 cubed plus 10 times 50. And then we want to plug 51 in. So then we have 50 cubed times 0.0002 plus 500. So that's 525. And we need to do the 51. So 51 cubed times the 0.0002 plus 51 times 10. It's 536.53. And then let's remember, this is two ordered pairs. This was when x equals 50. This was when x equals 51. And remember, these are like our y values. So we're going to be doing the slope of 536.53 minus 525 over 51 minus 50. The bottom is just 1. The top ends up being 1153. So that's pretty close to what we estimated using the derivative. That's the actual change. Okay. We did this one in class, and we did the lemonade function. We walked through how to get that. The only thing we didn't do is plug in 530 and 700 into our function. I'm pretty sure you guys were good with the formula we had, and you just had to plug and chug there. I believe when you do 530, you get 0. And then when you do this one, you get a negative answer. And what that means is that there's a certain point with some profit functions that you see that it's no longer beneficial for them to be selling that many, because some profit functions actually are not linear, they're quadratic. So they'll have a peak where they're at, before it starts going down and the marginal profits actually get smaller or negative. So just a FYI on that. My next video is going to be about, remember, the product and the quotient rules. I'm going to do an explanation as best as I can without theory involved of the two rules, and then we're going to do a couple of easy ones of each. All right.